Igielski. I work as a lead front-end developer at Snowdog. And today I'm going to talk a bit about the front-end performance in Magento 2. There is a little bit different talk for me because most of the times I talk about replacing some stuff. Today I'm just going to talk about optimizing it and squeezing the performance. This talk is not going to be about the PWA initiative, just because it will be released probably in 2 or 3 years. As James mentioned on the Twitter, the first beta tooling probably will be released on the Imagine 2018. So we can imagine that the PWA stuff will be released within 2 or 3 years, or maybe even more. So we have to care about current state, not really what the future brings us. Why should we care about the performance at all? First of all, the performance means the happiness of your users. Happy customers mean that they convert a lot better, so it means that we have more money. And more money means that we have a lot of more things to develop. So how we are going to measure the performance? Of course, this is just one of the many ways. It's not the ultimate solution, but I choose the solution that it's open source and it's easy to use in both of the client side and the server side. You can easily use them on the continuous integration or some monitoring stuff, and also it's good for the development. So that's the lighthouse. And it's not a structure, as you can see. It's a tool to become the light or to the warn or guide the developers that they are doing something wrong or they are doing something good. It's a Google tool, so we have almost some kind of insurance that this tool will be in development for next years, and they are really caring about the performance. Also, the lighthouse is not just about the performance, it's even more like about progressive web applications. So all stuff related to the service workers and stuff related to the progressive web application also can be checked and measured using the lighthouse. And that's the structure of the lighthouse itself. So first we have a bunch of gatherers. So they are just loading the page and scrapping the data. Then we have a bunch of audits that are parsing the gathered data. And we have this auditing data come from using the JSON, in the JSON format, to the report. And we have the 4 categories. That is, the first is the PWA, so it's related to the service worker, etc. The second one is the performance that we are today going to discuss. And we have also the accessibility that Anka talked today, and is also a really good tool to check it. And the best practice, which is a pretty general topic like, do not load so many content on the page, keep the request number low, etc. So how the lighthouse works from our end, so how we from our perspective. It runs the clean instance of the Chrome, but not always. You also can use the Lighthouse directly in your browser as an extension or the part of the Chrome developers tools. There is the audit tab. But even in this mode, it runs the browser in the debugging mode. So basically, all of your extensions or all stuff that can somehow affect the performance is already disabled. By default, Lighthouse emulates the size of the Nexus 5X and throttle your computer CPU to emulate the smartphone performance. It's usually like 5 to 10 times slower than the regular CPU speed. And also the network is throttlered to the slow 3G. So basically it's like a 500 millisecond delay on each request, and the max throughput is limited to 2 megabits per second or something like that. It's pretty slow, really. And how to use the Lighthouse. The easiest way, of course, is to just open the Chrome developers tools and the tab Audit. But currently, the Lighthouse built in the Chrome, it's a little bit outdated. So as you can see, it's version 2.0. But the latest one you can install from the Node Package Manager is 2.4.0. And the results may vary. And in my case, it was really painful, so watch out. The second one is the Chrome extension that basically you can install and click on the right, like a, I don't know, a blocker or something like that. And the third, the most powerful and recommended for me is the CLI. So basically an npg install Lighthouse, and you have this on whole system, and then just type the Lighthouse in the console, and you are ready to go. So that's how the report of the Lighthouse looks like. As you can see, there are the 4 categories: so the progressive web app, performance, accessibility, and best practice. Each of them have individual index from 0 to 100, and it describes how your page performs in each categories. And below you have the detailed description on each category. So basically, and you got some insight about each category. So in our case, in the progressive web app category, you have the information that the configured, it's not configured for the splash screen. So basically, there is something wrong with your manifest.json file. And the second one is the access bar matches the brand color. So there is no tag added in your HTML. And that's really good insight, because you probably should fix it. Then in performance, you have, in example, the timeline of the screenshot, so you can see how how the page was loaded. So basically, you have few frames, and you can see that the first meaningful page was somewhere around 1.3 seconds. And then below this, you have the numbers itself. So you have the first meaningful pane, the first interactive, and the fully interactive, which is cut because it does not fit on the screen. But we will see it later. So let's start with the Magento stuff itself. Because many of you are asking, should we enable the merging? You know, we have the HTTP2, so merging, what year is it? Should we enable the bundling or not? You know, someone say that, you know, everyone uses Webpack, so we should enable bundling or the minification. I don't have time for it, yeah? So let's see the numbers, how each of these options perform. So first of all, you should always enable the minification and merging because it saves data. That's how the gzip and other compression algorithm works. And of course, reduce number of requests. If we compare the not merged and not minified page with the merged and minified, you can see that there is like a 1 to 1.5 second difference in loading time, and basically there is 0 configuration needed for it. But there is a little small issue with Magento 2 when you are running on multi-node, because the merged file are not generated during the setup content deploy, because the files are generated dynamically. So you have to carry about the synchronization between the nodes, or just run it on the separate server just for the static content. And the second thing is this to bundle or not to bundle. And there will be a small plot twist, because right there I'm saying that not bundle, but yesterday when I stuck in traffic to the food in the main hall, Anton Krill approached me and just asked me how I'm dealing with my JavaScript stuff. And it comes out that Anton wrote the configuration for AirJX, which is an optimization tool for require.js. And I spent today morning on doing this stuff. And I have more slides on it on the end of the presentation. So just stay tuned. But basically, do not enable bundling in the Magento 2 from the admin area or whatever. It makes your page slower just because of this. So basically, when you enable merging, it takes all of the modules and then merge them together to one really huge file. It's like a 1 megabyte or something like that. After the zipping, of course, and put it in the head as a synchronously loaded JavaScript. So as you can see, it's like 4 seconds of parsing JavaScript at the beginning of the page, and basically in this time browser can do nothing and just parse the JavaScript. And as you can see on the not bundled version, it's only 700 milliseconds. But not only, it should be like 100 or 200. In Magento terms, it's only. So, what's our starting point where we should start our optimization? So we are starting with Magento 2.8.1, so basically the latest stable version. With the sample data installed and the Luma theme, the minification and merging is enabled and bundling is off. And there may be a little bit confusing part, especially for local development. I enabled the HTTPS, HTTP2, and gzip. In my opinion, that's the gold standard, and there is really no point that why you should not use HTTPS or HTTP2 or gzip, really. If you have any objection, just, I don't know, read something, or just approach me after the presentation. I'll describe you why it makes no sense at all. So that's our entry point. We have the performance scores of 52, and these numbers are really important. So great. So the first meaningful pane is about the 3.5 seconds. The page is interactive after about 7 seconds, and consistently interactive, which means that all resources are loaded. It's about 80 seconds. So it's not so fast at all. And then we have a list of the opportunities that we can take. So we can see that we are losing like 1 second of the loading time just for the off-screen images. So basically, we are loading the page with all of the images, even if they are not visible at all. And then we have our style sheets are also blocking the rendering time, and we are losing also about a second. Then we have this render blocking scripts, which take like 700 milliseconds, and there is a WebP, which we are losing only 100 milliseconds. So for now, we don't care about it. So let's do this because there will be a lot of job to do. Come on. So first step, we need to create a theme, because somehow we need to override some parts of the Magento to make the things happen. This theme that I created is already open source on our GitHub, so you can just go there and run it. It's not that much coding here. It's more like it's a proof of concept. It's not, for sure, it's not ready to use anyway. So, as I mentioned before, we need to analyze this Lighthouse report and take out the opportunities from them. So the first thing will be to annihilate the render blocking resources, because that's basically let us to render the page way faster than now. And of course, my favorite word, the asynchronous thing. Everything should be asynchronous, really. Even the communication on your team. Let's start with the asynchronous style sheet, because asynchronous JavaScript is not enough. And you can save here like 800 to 100 milliseconds of the initial, from the first time to the first meaningful reply. And I'm going to do this with the real preload. It's not supported well in Magento itself, because all of the style sheets are loaded through the layouts files, so there are limitations what kind of tags we can use. But we can simply replace it, and that's the XML file in the Magento team part of our team. So we are removing the style sheet itself. So basically, any style sheet that was already added via layout in any place in the code should be removed. And we need to load the polyfill, because the real preload is not supported in every browser. The support is pretty high, it's like 80 or 90%, but still there are some browsers that need to be polyfilled. And remember to load this file as an asynchronous thing, because we don't want to add any more JavaScript to the page to stop the rendering. And then we need to do some kind of nested thing, because we can't use the layout to add our style sheet. So we need to override the root PHTML, which basically is a really root of our theme. So we are using the link tag. The ref will be the URL to our style sheet. And as a rel, we are using the preload. As we are using the style. And then there's a tricky part, because preload itself does not execute the style sheet. It just downloads the file and that's it. So we need to fake the browser somehow and tell them, okay, so if you load this file, so basically onload event, change the real to the style sheet. And then the browser will know that this style sheet should be executed. Of course, this makes some issues, because as you can imagine, there will be no style sheets for a few milliseconds on page. So basically, there is a possibility of the flash of the unstyled content. And we will deal with it a little bit later. And that's the part that we should, how we should deal with the little moment when we don't have our full style sheets on the page. So there comes the inline CSS. The whole idea is about putting the small portion of the CSS up to 14 kilobytes, and that's by the limitation of the network protocol, directly in the head. It calls in a very different ways, like a critical CSS or the above default CSS, but also you can place there like a placeholder or some kind of loader or something that will make the user know that the page is loading, so he has to wait, but still get some kind of information that there is not just a blank page or something like that. And using this technique, you can save like up to 1.5 seconds of the initial loading time, because this style sheet will be invoked almost immediately after the first request from the server will come in. So if your server responds in like 100 milliseconds, the style sheet probably will be parsed within, I don't know, 200 milliseconds or something like that. So almost immediately user will get some kind of information on the screen. So there are two ways, as I mentioned before. First will be to generate the critical CSS and inline it. It is the best way for sure, because you render the page itself, not some kind of placeholder. But it's not easy, especially with the Magento 2 code base. I try to generate the critical CSS for the Magento 2 Lua team or blank team, and I end up with like a 25 kilobytes of style sheets, which is a bit too much to put in the head. So I decided to go with the second approach, just route the really simple placeholder that will cover whole page until the page itself will be loaded. So this placeholder, I don't measure how big is it, but it's like it's not that much. So it's, I don't know, 1 kilobyte or something like that. And it just, as you can see, it's like on the body I'm adding the before and after, which is a position fixed, and it covers whole page, and there is a slick animation that just flow on the page until I will get the actual style sheet and render all of the stuff. And I had to add another hack. So basically, when my style sheet is loaded, on the document body element, I'm adding the class loaded. But this solution doesn't work, to be honest, because sorry, it works, but not in all cases. There is a possibility that this onload event will happen faster than the DOM itself is loaded. So we need to listen for the DOM loaded event and then add this class. But it's, you know, like 50 more characters to type. But still, this approach is really cool and makes the response pretty fast. The second thing that, in my opinion, is the simplest and really important, especially on the content-heavy website, but the content is mostly like a video or images or some marketing stuff, etc. It's a lazy loading. It's not only image, but also the video and the other stuff that the developers don't really like. And you can save there like up from 500 to 1,500 milliseconds, or even more. Really, it depends how the page looks like. And the implementation is pretty simple. You take one of the lazy load libraries, like lazy CSS. This one is pretty cool because it does not require any additional dependencies, so you don't need a jQuery or something like that. And it works pretty fast. And then put, you need to load this JavaScript file, and remember about the async flag, because we don't want to load this JavaScript code synchronously to block the rendering time. And then you need to modify a lot of the code in your code base. So basically, any source tag in the image need to be replaced by data source, and you need to add the class lazy load to every image to know let know the lazy loader that okay, there is a content that you should load. Otherwise, there will be nothing, just a hole on the page. Also, you need to remember that if you have any content modifier, so the client is working on the page or something like that, he or she also need to remember that to use exactly same approach. So if you are adding the image from the admin area, they also need to use the data source, not source itself. The lazy sizes also work good with the responsive images. So there is no worries, you can use whatever you want. Just one, thank you. The second thing related to lazy loading is the low quality image placeholders. So basically, instead of using just data source, you are putting the source between them. And the source will be a low quality image. So in example, you are by default loading 500 by 500 and it's a JPEG like a 80 quality. So instead of that, just load 100 by 100 and the JPEG quality like a 20 or something like that. It will be pretty crappy, but when you write a few lines of CSS, you can add blur on this image, so there will be no pixel visible, and still user will get some almost immediate response that, okay, there will be an image and some kind of colors of this image, so we'll know that there is something happened because, I don't know, the network is slow or something like that. And that's a really cool approach. And there is a link to describe how this thing is working. Of course, it will increase the amount of data that you have to store on your server. So if you're running few thousand of product or something like that, there will be the effect on the storage. Also, the number of requests will be a little bit higher because for every image you will have to download basically 2 images, and the low quality and the normal quality. And do not overuse it. So basically, put the low quality images only in places that should be visible almost immediately. I don't know, the home page, the landing pages. So the places where user accept the immediate feedback, not everywhere, because you will get exactly same or very similar performance than with loading the full quality images. Yeah, because you will postpone the first render time just because the browser needs to download the images before, and it will be slower. The next thing is, of course, avoid using any kind of synchronous JavaScript. So basically, if you have any third-party extension, there is really high possibility they are loading the JavaScript the synchronous way. So basically, they are just adding them to the layout file without the async flag, or they are not using the required JS, and it just makes your page slower. And often they are even loading the same libraries that are already loaded on the page, like a jQuery or something like that, just because they want to be sure that your page will run with their code. I will recommend to remove the extension itself and run it once again. Do not even try to fix it, really. The next thing really cool about the new stuff in the HTML tags, it's the prefetch. It's almost the same thing like a real preload, but the preload have the higher priority. There is no way to, so basically, if you have the prefetch, the browser cannot load this file. So if the main thread is busy, it will just ignore it and nothing happens. But if you use the preload, it will load immediately after it's parsed. But still, even if the browser will just can ignore this construction, you can save here like 50 to 300 milliseconds just by loading a few of libraries that are used on the page, so like a jQuery UI, knockout, and the underscore. So if we know how to annihilate the render blocking stuff and make the page to render the content fast itself, we need to reduce the payload because it's also a little bit too much to load on the page. The first things that might be not obvious is to merge the style sheets. And in Magento 2 by default, we have the style-m, style-l, which should load conditionally, it depends on the image size. But if we really test it, how this performs, it makes no sense at all. It's better to merge all of this file together and serve as a one. because it's faster. That's the whole story. Optimizing images. That's a never-ending story, especially if we are dealing with users that maintains the content itself. There are always tend to load the file that are too big, or it have the JPEG quality 100, and even if you try to load it without losing quality, you can't optimize it. So basically, education, and then education. I hope so. Some of our clients are here. I'm not sure because I don't know you. But really, optimize images before you load them. That's the key. Of course, there are tons of ways to automate it, but still there is a probability to optimize this image to match. So we really need to scrap the size down. We probably need to use the lossy algorithms. So there is a chance to optimize it to low quality, and the image will looks like a crap. And there is a buzzword that the GC should ping me on the Twitter that I should talk a bit about it. So it's a WebP, but the GC is on the master's panel, so we can talk right now. Basically, WebP, it's a format like a JPEG or the or the PNG that was invented by Google, as far as I know. Of course, it's an open standard. There are no limitations to use them. And it's designed to be something between the JPEGs and the PNGs. So the WebP supports the transparency, but it also introduces better compression algorithms. So the same image saved with the same quality in the WebP will be like a 20, 30 to 40, even to 50% smaller than the JPEG. So it's really worth to dive deep into this topic. The browser support is of course not 100%, but right now it's about 70% or something like that. So it's pretty high because if the Chrome support it's like a 60% plus. So if one more browser will support it's a pretty good amount. And still there is, we don't need any polyfill for it or something like that. Just use the picture tag, and the browser will automatically detect if it can use the WebP or not. So it will be prioritized and load instead of the JPEGs or PNGs. The second thing about the images is to use the responsive images. And by the responsive images, I don't mean to set them with 100% and scale them down in the CSS, because that's not the responsive images. I mean using the picture tag with the media queries inside of it to load conditionally the image that fit into the user browser. So by default, it's okay to use the 3, 4, or 5 breakpoint, depends on the content itself, and squeeze down the size of the image depending on the screen. And you can save there like a 50 up to 17% for each image, because if you are serving it in like a 1000 for font of 5000 by 5000, so it probably weighs like a 300 or 400 kilobytes. When you size down it's like a 400 by 400, it should probably weigh like a 30 kilobytes or 50. So it's really it's worth to optimize the images in this way. But it's also good for the clients from the content side, because every client wants to load on the home page the slider with the banners. So there is 100% of the sites just run these banners. And most of the pages can't deal with the scaling of these images at all, because the proportion of this image is like a 60 by 9, usually, or something similar. So we have like a 1200 by 500 pixels or something like that. Let's imagine to scale it down to 320 pixel wide. So the height of this banner will be like, I don't know, 50 pixels or something like that. It will be the size of the button. So imagine the content that is on this banner. So there is no way to read it at all. So they can create few versions of the banners depending on the on the screen size, and then easily replace them depending on the browser size. So that's not just the performance, it's also the UX probably, and even maybe we can increase the conversion rate or something like that. And the next step will be to reduce number of fonts, or do not use fonts at all. That may sound crazy for some of you, especially for designers, because they love to use the web fonts, maybe like 10 different fonts on each page, in different weights and etc. But if we calculate down how much data do we really need to load all of these fonts, it's a really huge number. So for 2 fonts, probably we need like 200 or 300 kilobytes, which is really a lot when we compare them, in example, to size of the JavaScript, because 200 or 300 is a really huge library for the JavaScript. If we are talking about 5 or 6, there will be the load time probably will be reduced by 1 or 2 seconds just to load the fonts itself. And that's why we should think about using the system fonts as much as we can, because the page really don't have to look exactly the same on each device. It should look good, but the font itself, it's not a content. It's just some addition to the content. So if we can ignore this part that there is some design thing, and we think a little bit more about the performance, we really should ignore the fonts part itself. But if you really have to load these fonts, because there is no way to force it, you should load this font in WOV2 format. And there is no other way to do it, to be honest. Of course, you need the fallback for the other browsers, but always use this format. And if you really want to load these fonts, read about optimization of the font loading. As I mentioned on the previous presentation, the Smashing magazine is loading the fonts to the local storage and then load them back on each when the user comes back. This graph on the left, it's the small part of the possibilities of the loading fonts. And if I want to describe each of them, I will lose like another hour to talk just about it. So there is a link with description of all of these methods. Loading the fonts to the local storage is tested by me, and it works pretty well. So that's one of the methods. And another thing related to the third-party extension, because I don't like third-party extension, do not applicate the JavaScript libraries. Especially in Magento 1, there is a lot of cases where the page have loaded like a 3 or 4 version of jQuery. just because each extension that was downloaded from the market comes with the different version of the jQuery. So we can easily calculate that each version of the jQuery is like a 100 kilobytes, so we are loading 300 kilobytes of unnecessary JavaScript. And analyzing it is a really key. So, what's the results of this optimization? So first, we managed to make the first meaningful paint like almost 2 seconds faster than on the Magento with the Luma team. The first interactive paint was also up more than 2 seconds faster, and the consistently interactive is also 2 seconds faster. So from the 53, as far as I remember, we go to the 68, and as you can see, that's the part of the possible optimization, and there is just the render blocking script. There is no off-screen images, there is no blocking style sheets, and the time of the blocking script was also a little bit reduced. As you can see on the timeline, even in the first frame we have something. The user knows that the page is loading. That's the loader that I wrote. It's just like a gradient that is coming from the left to right. It's nothing fancy. And then you can see that the content itself is loaded, but the images are still loading. So there is also a chance to make some kind of placeholder for these images to make the user feel that, okay, there will be something in a second. But there is a plot twist that I mentioned on the beginning. It's related to Anton Krill. And I was working on this this morning. That's the URL to Anton's Krill repository with the RJX configuration. And there will be a little bit backstory because I don't have enough time to create the slides for it. So basically, the optimization that Anton's did are highly manually. So there is no, for now at least, there is no way to automate it. There's even no way to ship it somewhere because every store requires a different configuration. And it does not work in the Magento 2.0 or 2.1. It works only on 2.2. And it's related to the updates of the. There is one plugin for the require.js that use the browser's features that are not supported by RJX. And when we update them, it starts working. So basically, just forget about 2.1 for now, or maybe you want to do this part manually. So this numbers come from 2.2 release candidate 3.0, so the latest release that is stable. And same as on the 2.1, the merging and the minification is enabled, and of course the bundling is off. The performance index is the same, it's the 53. These numbers may vary from the 2.1 a little bit. But right there we have almost the same numbers. So I run the optimization that Anton mentioned in the way that Anton described in the documentation, but there is a little issue. So as you can see, there is a sync. So it means that JavaScript that we the bundle that we built, it's loaded synchronously. So as you remember on my previous slide, if something is synchronously, probably it's not so good. So And as you can see, even if we scrap the consistently interactive time, like 14 seconds or something like that, our score does not rise up, just because the first meaningful paint and the first interactive are almost not touched, or even are higher than before. And that's before of this. And because of this. So we need to wait a lot of time just to load this huge JavaScript file that is loaded synchronously. So I managed to do it a little bit better way. Oh, sorry, I switched the slide a little bit too fast. So that's the that's the score with the Anton's optimization. So basically, we are losing 2.5 seconds just to parse the JavaScript, because there is like a 500 kilobytes of the JavaScript in a single piece. So there is a lot of time necessary to parse it, and that's my score. When I load the bundle, the same bundle generated using exactly the same tool with a little bit different configuration. I'm going to show it in a second. And my performance index was the 68. So basically, if we combine the optimization that I did on the 2.1, which also gives us the performance index of 68, with this bundling, we've also increased the performance index by almost 20. So we probably will have this, the performance index about somewhere between the 18 and 90, which is pretty good. So let me show quickly how it's done. So whole process of creating a new bundle starts basically in this file. That's the configuration file for the RJX. RJX is an optimization tool for the required JS. So the structure of this file is quite similar to what we can see in the required JS config. And we need to pass the base URL, which is the file that that's the directory when by default Magento generates the static content. So in the standard way, it will be this file basically. So the file that is generated for a single language, and so you need to run the static content deploy before you create the bundle manually using the RJX. So you need to rename this folder for the source or something different. Then right there you need to pass the path to this this folder. So let me put it there. And then the directory, it's a output folder. So basically it should be almost the same, right, like this. But we need instead of the source, we need to pass the NUS, US. And that's all of the configuration, not really related to the code itself. Then we have the configuration, as there is a comment. All of these things are copy paste from the required JS config that it's merged together. So it requires a lot of manual work, because if you open the required JS config, there is no one big object, but it's just like a few smaller files combined together, one after another. The configuration, as I mentioned, is exactly the same as required JS. So we have the shim, we have the paths, we have the map. So basically, any module that is already used on the page also should be in this file. And then there's the part when we are defining really what the modules should look like. So it's an array, and in this place, that's the point where we are defining what modules should be included in which bundle. So we have the bundle default, which load the jQuery, all of the jQuery related plugins, all of the Mage plugins. So basically there is lots of dependencies that are required on almost every page load, or even not almost, on every page load. And then we have another bundle that is just for the cart, with lots of the modules. And then we have the one bundle for the checkout, for the catalog, and for the product. So running the, sorry, I can run them right there. So it's, we are passing the build. So that's the point, sorry. So that's everything we need to run from the console, basically. So just run the RJX, and we are passing the build.js file that contains all of the configuration. And then from the source directory which were there, the RJX parsed all of this stuff and put it into the output directory, which should be used by the Magento itself, because the structure is exactly the same, and the RJX can parse not only the JavaScript but also the CSS and basically any kind of static resources. There is an even way to optimize the CSS using the RJX, but I didn't touch it, to be honest. So there we have the bundles folder, which contains all of these bundles, but right now we need to load this bundle somehow. So we need to go to our team and create a required JS config. And there is an option of the required JS that you might not know. That's the bundles. And so the bundles defines the bundles itself. So each bundle, somehow we need to know what's the content of the bundle. So we are defining that the default bundle inside of the bundles directory contains the jQuery underscore and basically list of all of these modules that are already inside of this bundle. So when the page asks the required JS for some module, it knows that, okay, this module will be in this bundle. So there is no reason to download it once again, just redirect it to this bundle. And that's the whole key to the reducing number of the requests. Well, because basically, right now on the page, using this bundling tool, do I have it somewhere? Probably. Oh, sorry, something is broken. Probably I need to refresh the cache. So I'm running it in a production mode, so there is the high possibility that I just break something. Let's see. Oh, no, never mind. Oh yeah. So probably I need to remove the stuff. So one nice thing about Magento 2.2, the static deploy content, it works really fast. So as you can see, there will be just a few seconds and everything will be ready, not like a 2.0 that we are waiting a few minutes. It's still faster, right?
For now.
Oh, come on, yeah. We do it 25 seconds, so it's not that bad. So, as you can see, I load whole page, and I just did 2 requests for the JavaScript files. And basically, I can make this bigger, yeah. The number of requests itself is at 29. So when you disable the bundling, it will be like 180 or 50, something like that. And also the number of the transferred kilobytes is lower because everything is bundled inside one file. It's gzipped, minified, and as you can see on the Lighthouse report, it just works faster. Okay, let's back to the slides. These things are already done, and I know something about it, and I know it performs well, and it's pretty straightforward to implement it on the page right now. But I have more ideas that are a little bit maybe crazy or something like that. The first will be to do something like that, like in Magento 1, that Bill Curtis from the MinB did, that it pairs whole HTML output, take all of the JavaScript text from it, and put it into the footer. So it basically makes the page load much faster because all of the JavaScript were loaded after the content was loaded. So that's the similar approach that we can take in the Magento 2, but it will be way harder. Just because we have the data image in it directly on the elements, and also we have the script text for the required JS components directly in the templates. So there will be a lot of parsing to not break anything. But I think it's possible to do, but for sure it requires some backend work because it's not that easy to parse everything. And the second thing will be to use HTTP to push heavier files. Of course, it makes no sense when you enable this new bundling, because there is no way there's no point to push the JavaScript libraries. But there is one problem with this approach. It works only on Apache, or you have to create some proxy in Node.js just to push some resources.
Bartek?
Yep.
Czas używany.
Oh, really? That sucks. So that's the almost last slide. So the third thing is to use the Broadly or Zop field. Read about this more because that's really cool. That's the better compression algorithms than the gzip itself. And the fourth thing, probably most important, especially for not only the first visit, but for the returning customers, it's to utilize the service worker, because you can cache anything. But same as the font loading is a topic for a different presentation itself. And further reading. The Smashing Magazine, if you are not reading Smashing Magazine, you should start it reading. There is a really good front-end performance checklist, which contains way more ways to optimize your page than I did on this presentation. And there is a link to our GitHub where you can find the team for the 2.18, and probably I'm going to work on this in the future, so you can see the stuff for 2.2 maybe, or something like that. I don't know if you have the time for the Q&A, no. But I have one more thing related to my shirt. There is a Hacktoberfest in October, And it really brings me on the stage, because 2 years ago I sent my first pull request on the GitHub, and then I started working on open source. Like half a year later, I started working on Frontools and SASS team. So it may be a breaking point for you, same as it was for me. So just take a part in this initiative because it's really cool. Okay, thank you. Wow.